Hello students, welcome back to 60 out of 60 in KCET Chemistry 2025 series. So today we are finally going to finish all the chapters, and the last thing that we are going to do today is the previous year questions of the chapter hydrocarbons. So I have selected top 30 questions from your KCET as well as COMEDK previous year question. So let us quickly solve them and then we will proceed. So let us see the first question here. That is, among the following, the set which represents the aromatic species. So in the previous class, I think previous to previous class, we discussed about the conditions of aromaticity, right? It should be cyclic, it should be planar, it should be conjugation, it should have 4n plus 2 pi electrons. Now comparing here, you know benzene is aromatic, we all know that. This naphthalene, let us check this one. Here you can find all the carbons are sp2 hybridized, okay, and there are 1, 2, 3, 4, 5 bonds are there. 5 bonds means 10 pi electrons are there, and I can represent it in the 4n plus 2 rule, right? 4 2s are 8 plus 2, 10 is, that is also there. So 1 and 2 is there. So in whichever option 1 is not there, we can definitely eliminate that, right? So here also 1 and 2, here is also 1 and 2. Now this example I have given you in the last class, that it is having sp3 carbon, so that is not there. So 3 will not be there, so this option is having 3, so we can eliminate that also, and option number D will be the correct answer. Next, if you see why 5 is not there, so 1, 2, 3, 4, 5, 6, 7, 8 electrons are there. 8 electrons is 4n electrons, right? Not 4n plus 2. So that is why this is not there. And this is very simple, similar example. You can see here conjugation is there, cyclic is there, sp2 hybridization is also there, okay? And coming to question number 2, the major product obtained when ethanol is heated with excess of concentrated H2SO4. So this is very easy reaction. In the preparation of ethene, we have studied ethanol. If you heat, we will get ethene as the product, that is CH3, if I have like this, CH3, CH2, OH. And if you heat it with concentrated H2SO4, then H and OH will be dehydrated from here, and you will get CH2 double bond CH2, that is ethene. Okay, clear? Next is question number 3, identify A and B in the reaction. So you have propene and HBr you are giving, okay. So this also I have told you Markovnikov's rule and anti-Markovnikov's rule. So if I have propene like this, okay, and I have HBr, okay. So what will happen here, this carbon which is having less number of hydrogen will take the so first one is peroxide. So peroxide will follow anti-Markovnikov's rule. So Br will go to the carbon having more number of hydrogen. So here bromine will be attached, okay. So you can see that is option number A. In here also this is not there, here bromine, here iodine is there, that is also not there, means here bromine is attached here, here also bromine is attached in the this carbon, so that is wrong. In the second C and D, bromine is attached to these two positions, okay. Next question is HI, so it will follow Markovnikov's rule, I will attach here, H will attach here, so that is why option number D is the correct answer here, okay. Next question number 4, arrange benzene, N-hexane and ethyne in the decreasing order of their acidic behavior, okay. So we know ethyne has the, what I can say, the H of ethyne is highly acidic, so that is first of all, then we have benzene and then we have N-hexane, so option number D. So now if you see, this order comes from the ethyne, benzene and cyclohexane, right. Now you see, if this H goes, this carbon is sp hybridized, this one is sp2 hybridized, and this one is sp3 hybridized. So the acidity depends on the electronegativity of the carbon. Since this is sp hybridized, it is highly electronegative, it can stabilize the negative charge better, so that is why ethyne will be first. So we can eliminate these two options. After that we know electronegativity order sp2 carbon will come, so after ethyne sp2 carbon, that is benzene, that is why option number D here. Next question number 5, peroxide effect is absorbed with the addition of HBr but not with the addition of HI to an unsymmetrical alkene because, okay. So now HI bond is stronger than HBr and not cleaved by the free radical, no. Hi bond is weaker than HBr bond, so that iodine free radical combine to form iodine molecules. Okay, so this is the correct answer. That is why we cannot find peroxide effect in case of Hi, because the weak bond is there in H and I. Okay. Next is identify X in the following reaction. So if this is not visible, I'll draw it for you again. So we have benzene ring, okay, and we have been given with 6 chlorine in presence of anhydrous AlCl3. So this one, if you have just seen in the last class also, this all will be replaced with chlorine and we will be getting option number B. Okay, you may get confused with option number A, but remember it will be B. Okay, next coming the alkyl halides react to required to prepare by Wurtz reaction. So if we want to prepare this particular alkyl halide, then which type of halides we should be taking? So you can see that 1, 2, 3, 4, 5, 6. So we need one group of 3 carbons and another group of 3 carbons, right? So you can see here there is 1, 2, 3, 4, 5 and 6. If I take this one, then I'll get a linear chain. I won't get this branching. Here if you see 1, 2, 3, 4, only 4 carbons are there. We need 6 carbon. Here if you see 1, 2, 3, 4, 5 and 6. Yes, if you mix these two, then we can get this particular structure. Here if you see 1, 2, 3, 4, 5, 6. Yes, this is also there, but this one will give you what type of alkene? Let me see. You will get like this, okay, and like this. Okay, 1, 2, 3, 4, 5, but this is not the structure that is required. Here what I will get? Here I will get like this, and then 1, 2, 3. Okay, so this is the structure that is required here. So option number C is the correct answer here. Next, identify the following compound which exhibits geometrical isomerism. Yes, so geometrical isomerism, you should remember it happens in alkene. So here it is an alkane, here also alkane. We can eliminate these two. Now but1ene if I draw, right? This is but1ene and both the groups of this carbon are same, right? Both the groups are attached to the same carbon. Both the groups attached to this carbon are same, so that is why this one will not show geometrical isomerism. Correct answer is option number A. Next, the reagent X used for following reaction is, so if you have H2 you have added, right? So you can use palladium in presence of carbon. Okay, so if you do not use palladium in presence of carbon, if you just use nickel or something, then this alkene will get converted to alkanes as well. So to stop the reaction at alkene, we need palladium in presence of carbon. Next, N-propyl chloride reacts with sodium metal in dry ether to give you. So this is nothing but your Wurtz reaction, N-propyl chloride, right? I am telling you how to solve without. So there is N-propyl means 3 carbons are there in one line, 3 plus 3, 6 carbon you will get. So in one line. So here you see 3 carbon eliminate, 4 carbon eliminate, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 eliminate. 1, 2, 3, 4, 5, 6 option number A. Okay. Next, toluene reacts with halogen in presence of FeCl3 giving ortho and para halo compounds. The reaction is, so if you remember, toluene reacts with halogen in presence of iron FeCl3 giving ortho and para. The reaction is, okay. So here this is an electrophilic addition reaction, okay. So we have electrophilic substitution reaction. Last class I told you why benzene shows electrophilic substitution reaction, because benzene itself behave as a nucleophile due to the presence of free electrons around it, right. So that is why option number D is the correct answer here. Next, question number 12, for the preparation of alkenes, aqueous solution of sodium or potassium salt of carboxylic acid is subjected to. So this is your electrolysis method, Cole's electrolytic method, option number C. Next, replacement of Cl of chlorobenzene to give phenol requires drastic condition, but Cl of 2,4-dinitrochlorobenzene is readily replaced. This is because, so you know the NO2 groups present in the benzene ring makes the ring much more electron deficient, okay. So because NO2 we have discussed, it is a electron withdrawing group. So if more than one NO2 group is present, it makes the ring electron deficient, okay. So if the now ring is electron deficient, OH minus, which is a nucleophile, can easily attack on that, right. So you can see NO2 groups make the ring electron rich, no. NO2 group withdraws the electron from meta position, no. electron NO2 dominates electron at meta position. No, NO2 withdraws electron from ortho and para position. Okay, so that is option number D. Next, electrophile that participates in the nitration of benzene, that is your NO2 plus. Okay, this is the electrophile. Next, identify Q in the following reaction. So we have COCH3, you are treating it with PCl5. Okay, and then you are getting, and then you are getting P, and then you are treating it with NaNH2. Okay, so we have this one, that is not benzene, sorry, 1 second. Okay, so now you have here COCH3. Okay, and then I am treating this one with PCl5. Okay, and then I am getting P, and then once you are treating this one with NaNH2 excess. Okay, so now here what happens, if you treat it with PCl5, what product will get here, this group, okay, will get 2 chlorines, like it gets a compound like this is formed, CH2. Okay, and here we get CCl2. Okay, it get reduced, and here one, yes, CHCl2 we get. Okay, now when you take NaNH2, HCl twice, it will be removed, and we get a triple bond here, so option number D. Okay, next, number of possible alkynes with formula C5H8. Okay, so let us draw 1, 2, 3, 4, 5. Here I will get, that is one possibility. Alkynes always comes on the terminal, right? So we can make a 4 carbon chain like this, and here I will attach the 5th carbon, that is there. And one more thing I can do is, I can make like this, and I will attach the 5th carbon here. Okay, so any other I can get 1, 2, 3. I think we can, okay, we can get more also. The number of possible alkynes with formula, this one, right? So I got 1, I got 2, I got 3. Let me try this one. Can we put like this? 1, okay, 1, 2, 3. Yeah, this is also possible, right? So we should also check about the H. So 1, 2, 3, 4, 5, 6, 7 and 8. This is done. Here 1, here 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this structure is not possible because here we have 9 hydrogens. Right, this is not there. Okay, next one, 1, 2, 3, 4, 5, 6, 7 and 8. Yes, this structure is possible. And here if I see, I have 1, 2, 3, 4, 5, 6, 7, 8. This is also possible. So we will get 3 structures, so option number A. Okay, next, the compound that reacts fastest with sodium methoxide. Sodium methoxide means CH3O minus Na plus. Okay, so this one is what? This is a nucleophile. So the ring which is most electrophilic in nature will react fastest. And electrophilic, how it will have? If it has electron withdrawing groups. So here you can see there are 2 electron withdrawing groups, here 1, here also 1, and here there is no electron withdrawing group. So because it has 2 electron withdrawing group, it is the least highest in electron deficient. Okay, it is highly electron deficient, and that is why it will react fastest with nucleophile, option number A here. Next, the correct statement. Okay, cyclohexadiene and cyclohexene cannot be isolated with ease during controlled hydrogenation of benzene. 1 mole of benzene and hydrogen, sorry, okay, 1 second, cyclohexadiene and cyclohexene, okay, cannot be isolated with ease during controlled hydrogenation of benzene. Okay, next, 1 mole each of benzene and hydrogen when reacted gives 1/3 mole of cyclohexane and 2/3 mole of unreacted hydrogen. Okay, hydrogenation of benzene to cyclohexane is an endothermic reaction. it is easier to hydrogenate benzene when compared to cyclohexene. Okay, you have to find the correct statement, right? So now if you see this one, it is easier to hydrogenate benzene when compared to cyclohexene. This is wrong, because in benzene you have to hydrogenate 3 bonds. In benzene, in this you have to hydrogenate only one double bond. So that is why this statement is wrong. Next, hydrogenation of benzene to cyclohexane is an endothermic process. No, when you add hydrogen, it is an exothermic process. So this is also wrong. Next, 1 mole each of benzene and hydrogen. So if 1 mole of benzene and 1 mole of hydrogen is reacting, when reacted gives 1/3 mole of cyclohexane. No, there is no cyclohexane will be produced if you use only 1 mole of hydrogen. So that is why this is also incorrect. This statement is correct. Cyclohexadiene and cyclohexane cannot be isolated with ease during the controlled hydrogenation of benzene. Okay, the reaction is so fast, it is very difficult to separate them. Okay. Okay, so this was the questions from KCET. Now we'll be moving towards some Comet K previous year questions. Okay, the alkene which on ozonolysis yields acetone will only is. So you will get only acetone, but if you here you do, you will get formaldehyde. Here also you will get formaldehyde, but yes, here if you do both the side, here one O, here one O. So it is like this. See, structure is like this: CH3, CH3. Okay, double bond. C, CH3, CH3. Okay, so now what will happen? The bond will break here, we'll get C double bond O and C double bond O here. So option number C. Okay. Next, in the reaction, this one, the product A is. So here you can see a reaction like this. OH. Okay, so if you get O plus H2 will form. Okay, so now this one will go out, and here I will get, see, okay, first what happens, see, let me draw the structure. You are giving H plus, right? So when you give H plus, this OH will accept this H plus and it gets protonated like this. After that what happens, this leaves out and we get here, this one is removed and we get a cation here, right? After that what happens, this bond shifts here. Okay, this bond shifts here. So now you see, this is 1, this is 2, this is 3, this is 4 and this is 5. Now this bond from 5 2, it goes and attached to 5 1. So I will get a 5-membered ring. Okay, I am doing this 5-membered ring. Okay, on the first carbon I have 2 groups here. Also now if this bond is breaking, I will get a carbocation here. Okay, this is 2, then 3, this is 4 and this is 5. Okay, now on the second position what I can do, this is a secondary carbocation now, but if this methyl shift takes place, we will get a tertiary carbocation. So there is a methyl shift here. Okay, and then you will get like this, carbocation is produced here. Then what happens, one H comes from here and we will get a double bond here. So option number D. Okay. Next, the mechanism of the reaction in terms of intermediate or type of the reaction is given below. Mark the incorrect option. Okay, so here in this process we will get a carbocation intermediate. Yes, that is correct. In case of HBr peroxide, we get a free radical intermediate. That is also correct. X2 is to this one electrophilic substitution. No, this is an addition reaction, right? So this is incorrect. Option number C. Next, the most acidic hydrogen atoms are present in ethyne. We know, option number C. Next, complete the following reaction and select the correct options. Okay, so here you have OH and you are treating it with something, you are getting phenol. So that we just discussed in the last class in the preparation of phenol. So if you use zinc, it will happen, right? So and for zinc, I think there is only option A we can eliminate, option C we can eliminate, because in option B and D we have zinc. Okay. Next, if you treat SO3H with something and it is getting converted to this one, that is your benzene ring, right? So now this one will happen if you treat it with H2O steam, okay, not H2O boiling. So this is wrong. So correct answer for this question will be option number B. Next, I will tell you next one, if you take chlorobenzene and heat it with NaOH, and if you treat it with nickel alloy, you will get benzene again. Okay, so these are little tricky, little harder questions from Comet K. Okay, next, the reaction of this particular compound with HBr will give you. Okay, So we know that this one is having less number of hydrogen, so bromine will attach here, like this carbon will have bromine. So that is here CHBr, CH2, CH3. Okay, so here bromine is attached on this carbon, that is why this is wrong. Here what happens, this OH is also replaced, so that is wrong. Here also the same thing. Option number B is the correct answer here. Next, in the reaction, so I hope this reaction is visible. The final product Z is, so first NaNH2 you do, okay, for this is a base, okay, so what I will get, this H minus will be abstracted. I will get here C minus like this. Now if you treat with CH3 and I, so CH3 is plus, I is minus, C will attach on CH3, so I will get CH triple bond CCH3, okay. Now if you add H2O and Hg2 plus, what will happen, OH will attach following Markovnikov's rule. So here OH will attach, okay, and here H will attach, this bond will break, and after that tautomerization will take place. So I will get, one second, yeah, so here tautomerization will take place and then you will get acetone. So this structure is like this, CH, okay, C double bond C, OH, CH3 and H, okay, H and OH got added, this is your Y, okay. Now what will happen, tautomerization will take place, this bond will shift here, this bond will shift here, and this will abstract this H, and we will get CH3, CO, CH3, that is acetone. So here option number C, okay. Next, from the following compounds, choose the one which is not aromatic, okay. So you can see here 1, 2, 3, 4, 5, 6, 7, 8 electrons are there, 4 N electrons are there, not aromatic, option number B. Next, similar to alkenes and alkynes, benzene also undergo ozonolysis. In the sequence of the given reaction, identify X and Y. So we know first, when we do ozonolysis, one intermediate is formed which is called ozonide, so that is triozonide, because we have here 3 double bonds, and then when you treat it with ZnH2O, okay, so you can eliminate these two, you will get glyoxal. What is this glyoxal? See, suppose this is there, right? Now what will happen, this bond will break, this bond will break, and this bond will break. So I will get a compound here, I will attach oxygen, I will attach oxygen here, so I will get like this. Okay. This compound is called as glyoxal, that is this one, okay. Next, which of the following reaction is expected to readily give a hydrocarbon product in good yield, okay, to readily give a hydrocarbon product in good yield, okay. So if you do this one, Cl2H, you get a mixture of primary, secondary and tertiary, so this is not a good yield, okay. So the best method is always from electrolysis, that gives us direct product, so option number C here. Next, which among the following is the most strained cycloalkane, and that is your cyclopropane, so option number C. Next, a reagent used to test the unsaturation is your bromine water, right? So unsaturation, this has reddish color, but when you attach or react it with any unsaturated compound, you get the reddish brown color of this Br2, it's decolorization, okay. So yes students, that's all in this class, and I hope that you have solved these questions. If you have any doubt in any question, please comment down. I'll definitely address it, and thank you for watching, and do not forget to subscribe the channel.